In the given question, plate AB constitutes an isolated charge parallel plate capacitors. The inner surface 1 and 4th of A and B have charge plus Q and minus Q. A third plate C with the charge plus Q is now introduced midway between A and B. Which of the following statement is not correct? Okay, so we have to find the incorrect options here. So first of all, we will see the charge distribution in case of parallel plate system. So what is the concept for parallel plate system? We know that if none of the plate is grounded, in that case the charge that is appearing on the on the outermost faces, left as well as right, is equals to half of the total charge of the system. So it has initially charge of plus Q, and this has a charge of minus Q here. Okay, and they are on the facing surfaces. Now plate C has come in between, that has a charge of plus Q. So if I calculate the total charge of the system, then this plus this will become Q itself. So it will be Q total is how much? That is QA plus QB plus QC, and that is Q itself. So charge appearing out the outermost face will be Q total by 2, and here also Q total by 2. So that is how much? That is nothing but Q by 2 here, and here also Q by 2. Now we can see that there is no direct connection between this plate and this plate, or this plate and this plate, and this plate and this plate. So charge of individual plates will be conserved because it is neither receiving charge from any of the other plates or from any external source. So charge on A on this side is Q by 2, so total charge on this is Q. So charge on this face will be how much? It should be again Q by 2, because Q by 2 plus Q by 2 will add up to give you Q. Now if this is Q by 2, we know that charge appearing on the facing surface of parallel plate systems are equal and opposite. Opposite faces are equal and opposite charges. So this is Q by 2, so this will become minus of Q by 2. Now because it has total charge Q, out of that minus Q by 2 is on this surface. So on this surface it must be 3Q by 2. Now it has total charge, you can add this 2, you will get that is same as Q here, so no problem. Now this plate has a 3Q by 2 charge, so the facing plate should also acquire the same amount of charge, minus of 3Q by 2. Now because it has total charge of minus Q, out of that minus 3Q by 2 is there, so on this side it should be Q by 2. That is what we have already assumed it by our theory. In theory this is basically taught in the class, so I hope you are able to relate it, and if not taught, then this question is of capacitor. In capacitor you will study this. So we have to choose the incorrect option. The surface 1 and 2 will have equal and opposite charge. So surface 1 and 2, yes, they will have equal and opposite charge, Q by 2 and minus Q by 2. So this option is correct. The surface 3 and 4 will have equal and opposite charge. So 3 and 4, that is also correct. The charge on the surface 3 will be greater than Q. So surface 3 is greater than Q. That is also correct. So A, B, C are correct. That means D option must be wrong. Let's check it. The potential difference between A and C will be equal to the potential difference between C and B. So A and C, the electric field is Q by 2 times A epsilon naught here, and here electric field is 3Q by 2 divided by A epsilon naught. So this has a greater electric field as compared to this one. That means their potential difference will not be same, and that's why option D is incorrect here.